Thanks. Hi all, nice to be here. I guess I'm bringing news from another world that will soon converge with big data. So first question, who feels him or herself confident to be able to define what blockchains or distributed ledgers are? Then maybe show of hands? Then maybe some introduction is in order. So first, a few words about me. I'm with the Budapest University of Technology and Economics, and I come from the Department of Measurement and Information Systems. Within that, we are mostly into fault-tolerant systems and distributed systems and such. Currently, in the last 2 years, I've been focusing on blockchains, education, research, and evangelism. The principal investigator of this track is actually Professor András Paterica, my direct boss. I am also now the appointed national national delegate to the ISO TC 307, the Technical Committee for Blockchain and Distributed Ledger Technologies. This stuff is being standardized. Actually, yesterday I was still in London at an ISO meeting. So, do you want to buy a bridge from me? Can I sell you some token, ICO coin? If not, that's no problem. I'm not that good a salesman. Instead, I will try to sell you a concept of building systems that use blockchains for efficiently and irrepudiably and in very novel ways using tracking and analyzing data. But what I would like to start with is distributed ledger technologies. Now, the concept of distributed ledger technologies is rather simple. There are many transactional contexts where we use trusted third parties, be that SWIFT or the government or simply a bank that we use for transferring money. Instead of that, if we have a technology, we could do such transactions so that there's no single third party that we have to trust, the members of the transactional system. Instead of that, all of us tracks the transactions that happen in the system, and we secure the system by reaching consensus about the transactions that we as a group agree to accept or not agree to accept. This is basically the core concept of distributed ledgers. The way we use this kind of disintermediation of trust, distributing trust from a single third party to a group, is that we have a typically peer-to-peer system of parties. Clients request transactions from this system. The system orders transactions, executes the transactions, and reaches some consensus about the acceptance of these. And at the end, all ledgers are updated with the new lines, the transactions that we deem to have happened. So, but how does that come to blockchain? Actually, what we call blockchain is a technological pattern that's currently the best way to implement such distributed ledger systems. And all what a blockchain does is that the transactions that are subject to consensus are put into blocks, and the system reaches agreement about the acceptance of the next batch of transactions in a such blockified way, and there are cryptographic links between each block to the previous one. And typically we can also program the logic of the transactions, be that simply a multi-party signature for wiring money, transferring crypto asset or real monies, or implementing something else. I will talk short about that a bit later. Why we love this pattern is the following. So this is actually, these ledgers are immutable transaction logs, so this is not just about cryptocurrency, although that's what bootstrapped this whole now blossoming field. We can use contracts to program transaction logic over ledger state. The ledger is shared across all participants, so everybody sees what is accepted to have happened. It's distributed, so replication, massive replication is baked into the concept itself. It's usually cryptographically authentic, meaning that as transactions are cryptographically signed, they are non-repudiable, we can use secure identities, and we can also tokenize assets of the real world or logical assets and perform cryptographically authentic transactions on those. And the last point is maybe the most important one. Trust is in the system because the fact that those parties have to reach a consensus and use some distributed consensus mechanism means that this whole concept is fault and attack tolerant up to some level of compromise of the parties. Okay. But the way you may have heard about blockchains is a very specific use case, cryptocurrencies, say Bitcoin, Ethereum, or some of the other alternative coins. It's a fact that Bitcoin is the cryptocurrency that bootstrapped this whole world. This was actually the first real distributed ledger technology in widespread use. It can be interpreted as simply a global peer-to-peer system that maintains a ledger of crypto money transactions. So without a central party, this whole global system of peers accounts for transactions that happen between parties. We are basically wiring amounts of Bitcoin between each other. Now, the incentive for the participants to take part in this system is cryptocurrency. So if you commit a peer or a mining rig to this system, you have some chance to get some amount of that cryptocurrency. And if you accept that to have value, then this means that your computer is producing you money. And this is actually rather inconvenient. Something I didn't think of. I'm sorry. Could you get me your... Van ott egy konnektor. So, okay. After that, many altcoins appeared, and the next wave of true innovation was the appearance of Ethereum that introduced true smart contracts, meaning that you have a token ledger in this global peer-to-peer system, but using little snippets of program, you can define your own custom ledger over that system, and you basically pay for program execution in small amounts of crypto money, and also these contracts, these small programs can define rules for managing amounts of that crypto money, but this is not our focus right now. There are a plethora of emerging use cases that have been emerging in the last 2 years, from crowdsurance through ride sharing and home automation, proof of ownership and decentralized storage. It's truly astounding that what people come up as usages for this system. And I won't delve into that. If you open up CoinDesk and look through their news, one can spend many an unproductive hour with amazing at the kinds of things that people try to put onto Ethereum. We are inching with this towards the Internet of Value, and there's actually truth behind the whole crypto bubble, if it's a bubble at all. This is something that works. We have a global peer-to-peer system that contains some crypto money, but over that ledger we can define the ledger of our liking. This means that we use Ethereum, at least right now, as infrastructure, sort of kind of like a global peer-to-peer cloud where program execution is really costly, but also means that a distributed system tracks very securely what I want to maintain as a program or contract state. But if it's really infrastructure, do you use the cloud for everything? If it's like the cloud, then we can pose the question whether we should use it for everything. Public blockchains today have some problems. By default, the whole world sees your ledger, whatever you want to do on this distributed system by default. and that's not necessarily good. There's variable transaction cost in crypto, not always good, variable and significant transaction delay, very low throughput of the whole global system, and by default the participants are pseudonymous, and when you have a requirement to know your customer, then that's not really a good thing. And yeah, this is something of a theoretical point, but finality of transactions is probabilistic. So why just not build our own such distributed ledger system? And you can do that. These are called consortial blockchains. By definition, this means that we have a set of organizations that gather together to build a blockchain that has some business incentive. They have a cooperation case where they don't trust each other at all, or just partially trust each other. And instead of paying for a third party to be the trusted third party, again, look at, for instance, SWIFT or your bank, they say that some majority of the whole consortium is enough for the system to be secure enough. For this to be able to happen, these organizations have to have some common business, but if they have that, they can build ledgers on a need-to-know for cooperation basis, and instead of using that whole cloudy global peer-to-peer system, they can bring their own peers. They have to actually bring their own peers. In this system, there's no need for a native cryptocurrency, so when you build a consortial ledger, you don't have to have Ether in that, say. And the ledger view can be actually a database. So we are inching towards a world where you can make consensus, group consensus, on the transactions of a true database. It's still secured by group agreement of a known group to that. So all the mining and proof of stake, you may have heard these very shady things, these are not required. Simple voting can be enough, majority voting in many cases. And given that it's not a global system, its performance will be much better, and PKI is in many cases baked in, but we still have all the nice things that we get from the DLT pattern. It's still the DLT pattern. It's just that we don't use a global system for that. That's working because the participants sometimes get some amount of crypto money. Instead, we gather together as organizations and build the same for us in a closed and permissioned way. So there are tools to do that. There are mature tools to do that, although this was still not true, say, 1.5 years ago. At the forefront of invention is the Linux Foundation with its Hyperledger software framework, open source tools that you can use to implement consortial distributed ledgers. In that project, there are a number of core technologies. Hyperledger, Fabric, and Sotus are the most mature ones, far past the 1.0 phase, and some other supporting tools, but the whole thing goes under the umbrella and governance of the Linux Foundation. Fabric was the first project that was incubated. It was first to graduate. It reached 1.0 phase first. It was original from IBM, but now it's truly open source in all senses. Here you can code smart contracts or chain codes in your language of choice, and it's actually not a specific blockchain. Bitcoin, the whole global Bitcoin ledger, is one blockchain. Ethereum, the various global Ethereum networks are specific, huge systems. In this case, these are pieces of software that you can use to build the blockchain that you want to for your consortial needs. And also you can, a bit ironically, you can spin it up in all major clouds now. So if you want to play with it, you don't have to hack at it, just go to Amazon or Azure or Oracle Cloud or, yeah, certainly IBM Cloud, or basically whatever you like. As a definition, what we have with Hyperledger Fabric is permissioned industrial strength blockchain platform for systems and application. What's quite a mouthful, but actually a good definition. So the way it works is that there are a great many things that happen here. What you see here is organizations bringing together nodes, actual computers, to all participate in a common ledger. And this is not something I should delve into. If this whole thing looks a bit like a Rube Goldberg machine, it's because that it is a bit like a Rube Goldberg machine. When you have enterprise needs, then the software that you will have will be enterprisey, because that's how the world works. It's still not as complicated as many classic enterprise softwares, let me add that. So what are the selling points? What is it used canonically? Asset and supply management is one. If you have a central system of record in the form of a blockchain, then when you have a supply management or asset management case, then a whole potentially global supply chain can be managed in a trusted and semi-synchronous way using this technology, and in a closed way, so not the whole world sees what's happening, whether your turbine or your new shiny refrigerator has been containerized already or not, just by the parties that need to see it. But all those parties sign digitally everything that they do with those. And given that there's consensus, a consortium-wide consensus about the transactions that we accept, nobody can say that, I'm sorry, but you didn't deliver that turbine to us, because the record is on the ledger that everybody accepts by definition. So there's a big use case by IBM. They did it together with Maersk for tracking of containers across ports and terminals. Ocean carriers are involved, customs authorities, freight forwarders, intermodal transport, and shippers. All these parties are brought together and enjoy the very properties of distributed ledgers that I began with, without involving any cryptocurrency and without opening up the system to the outside world. And we are seeing in consortial solutions popping up day by day for payment. Maybe think a bit about SEPA here. Insurance, supply chain management, healthcare, and so on. And why should you care? I will try to talk about data here. So this is not the only thing that you can use such a tool for. When computer scientists get a tool, they try to use it for everything. So this is our hammer. Let me show you what we try to use it for. There are many data-centric cooperation patterns where such distributed ledgers can be immensely helpful, and this is my main message here today. There are many interpretations of a distributed ledger, so I will try to follow a very simple taxonomy. When you have such a distributed system, you can simply use it as a middleware. So that ledger that you put together and program its transaction logic using pieces of code, you can simply use it for messaging. You can do a ledger-based publish-subscribe approach, or you can replace message queuing. The difference between the classic techniques will be that you have a ledger that's backed by a blockchain, and whenever you want to go back and see whether a certain message has been sent by a certain party, you have that on your ledger, and it's irrepudiably there, cryptographically signed. You can also use it as storage, either for full data, for aggregates, or simply linking parts of databases via cryptographic hashes into the ledger. This won't be the same as a SQL engine yet, so or even a big data engine, don't expect terabytes of data. But this is something that you can do with consortial technologies, and you definitely can do on public blockchains, because storing even little pieces of data costs you quite much. You can also use it for cross-checking computations. Remember, there's a set of organizations, and all of them run the code that we accept as transaction logic. And if someone sees something fishy, then they simply won't accept the result. And if enough parties don't accept the result, then the result of the transaction won't go into the ledger. Sure, this you may want to potentially offload to a big data backend, but still the pattern is there. In each case, data provenance and the irrepudiability, yes, of transactions, the data that comes in and the stuff we as a consortium all do on the data is there. So you don't have to go any further. It's in the technology. That's what the technology is about. Some simple use cases that we put together. This is the just for messaging use case. You have a sensor somewhere. You have a signal actuator. If you see that there, that's the innovation of my professor. There's a big red button. So if the sensor sees something fishy, for instance, a door is open that shouldn't have been opened actually, it posts that message cryptographically signed onto the ledger. The signal actuator sees that message appearing on the ledger. You can say backwards that, OK, I decide to shut down the machine. That command goes onto the ledger and goes back to the equipment. The difference between classic field communication technologies and this is that everything remains signed and in a signed way on the ledger. And if you want to audit, you don't have to do periodic audits, because you can do audits actually continuously on a ledger using smart contracts in a programmed way. We did put together a mobile client and some, well, not that nice, but working front end for this. But the core message is that putting the messaging use case onto a ledger brings you things that you simply don't get from classic approaches. Now, this is something that you don't do with public blockchains, because what can you get? 10 transactions an hour if you don't want to pay too much? Let's just see what can you do with Hyperledger Fabric. This is 3,000 transactions per second. That's not bad. It's actually from the paper of the tool architects. You can also use it for logging of hazardous incidents. What we have here as a scenario is that we have a process, something happens there, the operator sees that, pushes again, we are a bit fixed on those big red buttons, the big red button, and the user data and operator interactions all go onto the ledger. The authorities can be alerted automatically, management can be alerted automatically, and what you see there as flight recorder do not open, this is actually the ledger. It's a stable audit log the same way as a flight recorder would be. And actually, there is serious data that we want to put directly into a distributed ledger. You can think of autonomous cars. You can think of more classic use cases in the safety domain. There's all the asset-related tracking stuff related to, for instance, shipping. What's the current temperature in the container? You want to have a log of that every half hour, maybe even 15 minutes, and so on. One layer above, you have stuff that nowadays you implement using mostly process management engines. There are multi-party data acquisition processes. You get your IoT data from one source, you do something on it, and you put it into the cloud. Is there real audit on that? Irrepudiability of who said what? Not really. There's multi-party data analysis. You can offload your data analytic tasks to a platform as a service or API as a service provider. They do something on that, something comes back, and that's that. Is there irrepudiability in a cryptographic way there? Not really. And there's also the need for, in certain domains, to continuously audit either data acquisition or analysis. And coordinating data access is something I won't delve into. You can actually do that on chain too. We have a solution that's, and we are trying to bring it to the market, that picks models of business processes where we have multiple parties, transforms that into a set of smart contracts, puts them on a consortium blockchain, and voila, your interaction that you want to do between the parties is logged each step, and everybody signs what they did or didn't do. Actually, originally, it was a Hyperledger 2017 summer internship for a PhD student of us. And the next step will be doing the same thing, not for BPMN, but for data acquisition and analysis. I assume most of you have seen RapidMiner models. Well, that's a business process. and that can be distributed too. So there's value in putting not necessarily the whole data flow into a ledger, but for the steps that the model execution is doing, definitely. And you can go even further upwards, where in the public domain you would have tokenization and token economies and initial token sales and whatnot. For the consortial domain, I would say that what you would like to do here is more like assetizing your data and assetizing data access and assetizing data processing. And you can engineer a consortial data market model to your liking, but this is still something that we are still very much experimenting with. But this is doable too. You can do, say, a marketplace for data analysis tasks where the various service providers can bid using certain token models or market models for the data analysis that you want to get done. That's doable too. Exchanges, replacing exchanges with consortial blockchains is one of the not earlier mentioned canonical use cases, and that's something like an exchange too. Your system will be closed here. That can be a plus, but can be connected to public ledgers too. Granted, if you go down this road, consortial blockchains, you have to actually engineer your blockchain. You can't just rely on Ethereum being there, but yeah, this gives work to engineer, so in a way it's a plus. Joking aside, the core message is that this is a toolbox you have to design, analyze, and implement, as we always did. So, before the closing remarks, and it's a miracle, but I still seem to be on time, a few words about us and Hyperledger. This whole line was bootstrapped by a 2016 IBM faculty award to my professor, Professor Paterica, and based on the work that we did since then, this month we became a full-fledged Hyperledger academic associate member organization, the very first from Eastern Europe. And we will be mentioned on the 30th of this month in the new members newsletter. We are very active in the performance and scale training and education work groups, and we do performance analysis in a rather serious way. So we take part in the development of Hyperledger Caliper, the performance measurement tool in Hyperledger. Mostly I also run a 200+ student blockchain course this semester. It actually wrapped up today. And we are now also offering industrial courses with a heavy focus into consortial/private blockchains, specifically Hyperledger, Fabric, and Composer. So now the closing thoughts. This is actually open. The community is open too, not just the tools, so come and join us, I guess. There's a Hyperledger meetup in Budapest now. Next session will be tomorrow. You can find it on meetup.com. We will be there, most definitely. This is a toolbox. For us, that's a plus, but this also means that right now there aren't many tools that you can buy shrink-wrapped for a given specific consortial data analysis and data-driven cooperation goal. In the whole space, there are some data-centric solutions that are already there. BigChain DB is worth a mention, but mostly the thinking about merging data analysis and blockchains, that whole thing began in a truly serious way in the last 6 months. And the last thing, if you have an idea or a story based on that, or what you have been thinking about earlier, we would love to hear it. Thank you very much.